Okay, so today you guys are going to learn about place value again, but instead of just the whole numbers that we've been learning, we're actually going to talk about decimals today. So, does anybody know what that dot back there is called?
No.
It looks like a period. What's it called?
A decimal.
Not a comma. What's it called?
Decimal.
A decimal or a decimal point. Good. So far we know our whole numbers. So going from to the left, right? So there's a decimal and we go to the left. So we have our ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, right? What was the pattern? We added what? So we start at 1.
And tens.
Then the 10. How many zeros does the 10 have?
One. None.
The 100 has how many zeros?
Two, and then 3, and then 4.
Yes, and so it just keeps increasing, okay? So it increases by 10 times. Okay, it increases by 10 times going all the way to the left. Now, today what we're talking about is after the decimal point. Our decimals, right? So we have tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths. What do you notice what I'm saying about those words?
S.
You have the
TH.
You have the TH.
The TH, the THS. Yes. And do I say once? Do I say once? What did I start at?
One.
No, when I'm talking about the decimals, what did I start at?
One.
Did I say once?
No. One.
What did I say?
One.
I started at the tenths. Who said that?
Oh.
Good. I started at the tenths. Okay? So those are two differences. So we're going to watch this video. I'll be pausing it every so often.
So it's 10, but you said with the 10.
Yes. THS. We start at the tenths, and this is going to explain why.
I don't hear anything.
I know. Sorry.
Hi, I'm Rob. Welcome to Math Antics. In this video, we're going to learn about decimal place value. As that name suggests, it's related to regular place value. So be sure to watch our video about that if you haven't already. In that previous video, we learned how to count using just 10 different digits and number places that represent different size groups. For example, if we needed to count 235 apples, we use different number places for counting by ones, by groups of 10, and by groups of 100. The digit 2 in the hundreds place represents 2 hundreds. The 3 in the tens place represents 3 tens, or 30. And the 5 in the ones place represents 5 ones, or just 5. It's a pretty amazing system if you think about it. It only has 10 digits, but those digits can be reused in different combinations to count any number from 0 all the way to trillions of apples and beyond. But, as amazing as it is, there's just one little problem with our number system so far. What if you don't have a whole apple? In the place value video, we only learned how to count whole amounts, or what we call whole numbers, which is the set of numbers you get if you start with 0 and then count by ones, 1, 2, 3, 4, and so on. But there are things besides whole amounts. It's possible to have just part of something, like just part of an apple. And that means there are in-between amounts. You might have 1 apple or 2 apples, but you could also have something in between that, like 1.5 apples. How can the base 10 number system handle situations like that? The answer is decimal places. Decimal places are a way of extending the base 10 number system so that it can represent amounts that are in between whole amounts. Decimal places are just like regular number places, except that instead of using them to count groups, we use them to count parts or fractions of things. To see how the base 10 system is extended with decimal places, let's look at the pattern of number places that we saw in the last video. We started out with a number place for counting things one at a time. And when we hit the limit of counting with it, we used another number place on the left side of it for counting groups of 10. By combining those two number places, we could count from 0 all the way up to 99. But when we needed to count beyond that, we used another number place on the left side of it for counting groups of 100. And when those places were maxed out, we added a place for counting by groups of 1,000, and then by groups of 10,000, and so on. See the pattern? Each time we added a new number place, it was located to the left of the previous one. And each time, it represented groups that were 10 times larger than the previous group. Since the amounts that our number places represent get bigger and bigger as we go to the left, it makes sense that number places for counting smaller amounts, like parts of something that are less than 1, will need to go on the right side of the ones place. That's where the decimal places are found. And, just like the whole number places can go on forever to the left, counting bigger and bigger groups, the decimal number places can go on forever to the right, counting smaller and smaller parts, or fractions.
Okay, so if you saw right here, let me play it.
Go on forever to the right.
So look at this. So he's talking about whole numbers, and then he's also talking about decimals. But what do you notice about this? If we had a number like this, would we get confused? Like it'd just be like a huge number. And he's talking about whole numbers and decimals. So what do we use to separate it?
Those things that you use, the period. But instead of using it for like stopping words, you use it to split the stuff. I forgot what it's called.
What is it called? It's not a period. We're not in English. What's it called? Math has its own language.
I'm saying it looks like a period.
Not a comma. Julian. Decimal point. It's a decimal point. Everybody say decimal point.
Decimal point.
It is a decimal point. That is what is going to separate our whole numbers from our decimal numbers. Decimal numbers, is it a whole? So is it one whole apple?
No.
No.
It's pieces of apple.
Yes, it's pieces of the apple.
Like half, quarters, piece.
Turn around, please. Thank you. Turn around. Okay.
Counting smaller and smaller parts, or fractions. But if number places go on forever in either direction, then how do we know which place is which? I mean, if they all look the same, or worse, if they're invisible, then how do we know which digit goes in which place? Ah, that's an excellent question. We do have a problem now that number places can extend in both directions. Before, when we had only whole number places that extended in just one direction, to the left, we knew that the place that was furthest to the right was always the ones place. But now, we know that number places can extend in both directions. So we need a new way to tell which place is which. What we need is a point of reference, a place that we always start from. And for that, we use a special symbol called the decimal point, which in the United States looks just like a period. Basically, the decimal point acts as a separator. It separates the number places that are used for counting whole values, which are on the left side of the decimal point, from the number places that are used to count fractional values, which are on the right side of the decimal point. And that's why you don't see a decimal point in every number. If there's no decimal digits in a number, like in the whole number 25, then you don't need to show the decimal point. It's safe to assume that the digit farthest to the right is in the ones place. Of course, you could still show the decimal point if you wanted to, since it's always immediately to the right of the ones place. But if there's no decimal digits, then we don't need to separate them from the whole number digits. If a number does have decimal digits, then we call it a decimal number. And the decimal point helps us quickly recognize which digit is in the ones place. For example, if you see a sequence of digits like this, 1, 2, 6, 0.53, you can tell right away that the digit 6 is in the ones place because it's immediately to the left of the decimal point. That means this 2 is in the tens place, and this 1 is in the hundreds place. Okay, but what about the digits that are to the right of the decimal point? We know that they must be in decimal number places, but what are the names of those decimal number places, and what values do they count? Well, looking back at our number place pattern, we see that each time we move to the left, the new number place counts amounts that are 10 times bigger than the previous place. So, each time we move to the right, that place should count amounts that are 10 times smaller than the previous place. Since the ones place counts by ones, the number place to the right of it should count by amounts that are 10 times smaller than 1. The amount that's 10 times smaller than 1 is called a tenth. It's the...
Okay, so when we're going to the left, so here's the decimal, and if we go this way, is it getting bigger or smaller as we keep going this way?
Bigger.
Bigger. And then here's the decimal. Smaller. Okay. So the first number place after a decimal is called a what? A tenth. Good job.
The amount you get if you take one whole, like one whole apple, and divide it into 10 equal parts, keeping just one of them. 1/10 is what we call a fraction. And fractions are written using a special notation that has two numbers with a line between them. The number on the bottom tells how many equal parts a whole amount is divided into. And the top number tells you how many of those parts you have. So the fraction 1/10 is...
Okay, so this number on top is called a numerator. What is this called? Numerator.
Fraction.
This down here is called a denominator. What is this called?
Denominator.
So the numerator, what does the numerator mean? There's a 1 up here. What does it mean?
I only have one of something.
Yep, he has one piece of the apple. And what does the denominator mean?
The denominator means
1/10.
What does the denominator mean?
Can I do it? Can I do it?
So yes, it's in the tenths place, but this number right here, so the numerator means how many pieces they have. The 10 was how many pieces the apple was what? Cut into. Good. So they have one piece out of 10. Okay? 1/10.
And we can say something else.
Sure.
When you get all 10, it becomes a whole number.
Correct. Good. And then it'll move over to the ones place, correct?
Mhm.
So what if they had 2 pieces of the apple? What would it turn into?
2 out of 10.
2 tenths. Good. What if they had 5 pieces of the apple?
5 out of 10.
Okay, good, but wait for me to call on you. 5/10. Okay, 5/10. I want you to use the language we're learning. Sorry about that. What do you guys notice about 5/10? So if you had an apple cut into 10 pieces, and then you kept 5 pieces of it, how much of the apple would you have? So I know it would be 5/10, but just looking at it, what do you notice about 5 and 10? 5/10. What do you notice?
that it's going to
Maybe you need a visual. Let's watch this for a little bit, okay?
written like this.
Oh, you know?
What?
What?
So 5 plus 10 is 15, so it'll be 15.
We're not adding. In fact, what does this line right here mean?
It means 1 is basically how much it's been cut in.
1 is how many pieces they have. 10 is how many pieces it's been cut into. But what does this line mean right here? What does this line mean? Divide. Good. So in fact, in fractions, we would be dividing. That's how they get the decimal point, okay?
Over 10. Getting back to our apple counting example, previously we could only count whole apples. But now that we have a number place for counting tenths, we can count tenths of apples too. We can use the ones place and the tenths place together to count amounts that are in between a whole number of apples. To see how it works, let's start our counting with 1 whole apple and no tenths. That means that there will be a 1 in the ones place and a 0 in the tenths place. But now, let's start adding tenths to that. For each tenth that we count, we increase the digit in the tenths place by 1. 1/10, 2/10, 3/10, 4, 5. Let's pause for a second to notice something important. Do you see that having 5/10 of an apple is the same as having 1/2 of an apple? That's because 5 is exactly half of 10. And the fraction 5 over 10 can be simplified to 1 over 2. That's why having 1.5 apples is the same as having 1.5 apples. Pretty cool, huh? Anyway, back to counting. 6/10, 7, 8, and 9/10. Now we have 1 whole apple and also 9/10 of an apple. But our tenths place is maxed out with the digit 9. That's as high as it can count. So what do you think?
So what do you think is going to happen now? What do you think is going to happen? So it's 1.9. I'm going to give you 20 seconds of thinking time. It's 1.9 right now. What's going to happen when they have another piece right here? Can you tell me what's going to happen when they add another piece? What's going to happen to the number?
It'll change.
It will change, but what will change about it?
Um,
Come on, you got this.
Jumping.
Okay.
It's so easy.
Let me think about it. That's the question to another person.
Okay. What'll happen to it?
The 9 is gonna be a 0.
Good. The 9 is going to turn into a 0. And then what other number will be changing?
The 1 is still gonna be 1.
The 1.
It's not going to still be a 1. What's going to happen?
It's gonna be a 2. It's gonna be a 2.
It's going to be a 2. Because now we're going to add another whole apple. Because one more piece would make a whole apple, correct?
Yes.
Okay.
Yes.
What will happen if we add one more tenth? Yep, those 10 tenths combine to form one whole apple, and that will cause our ones place digit to increase to a 2. We now have 2 whole apples. Even though one is made up from slices, the amount is still equal to one whole. See how decimal digits help us count in between whole amounts?
Yeah.
But wait, there's more. More decimal number places, that is. The tenths place allows us to count in between the ones. But what if we want to count amounts that are in between the tenths? The decimal number places keep on going to the right, and each time they count amounts that are 10 times smaller than the previous amount. So, if the tenths place counts fractions that are a tenth of 1, then the next number place over will count amounts that are 1/10 of a tenth. 1/10 of a tenth is called 1/100th, and it's the fraction you get if you take a tenth and then divide it into 10 equal parts. It's a very small fraction, and it's called a hundredth because it's the same fraction you'd get if you take a whole and divide it up into 100 parts. So its fraction form looks like this: 1 over 100. Just like tenths could be used to represent amounts that are in between the ones, hundredths can be used to represent amounts that are in between tenths. And just like if you combine 10 tenths, they equal 1. If you combine 10 hundredths, they equal a tenth. And the decimal number places keep on going like that. The next number place over represents fractions that are 1/10 of 100. That very small fraction is called 1,000th because it would take 1,000 of them to make one whole. And the next place over is 10 times smaller than that. It's called the 10,000ths place. And then there's a 100,000ths place. There's a millionths place, and so on. So do you see how truly amazing our number system is? It can represent any whole number amount, no matter how big, by adding bigger and bigger number places to the left. But it can also represent amounts in between those whole amounts, with more and more precision, down to the tiniest fraction imaginable, by adding more and more decimal number places to the right. That is truly amazing. In fact, it kind of makes my head hurt just thinking about it. Of course, it would be this doggone pot I wear in my head all the time. Okay, so now that you know how decimal places work, let's talk briefly about how we can show their place value and how we can write decimal numbers in expanded form. A digit's value is determined by the place that it's in. So, if a 2 is in the tenths place, it stands for 2/10ths, which can be written with the fraction 2 over 10. If a 3 is in the tenths place, that stands for 3/10ths, or 3 over 10. If a 4 is in the tenths place, that stands for 4/10ths, or 4 over 10, and so on. And just like a 2 in the tenths place stands for the place value 2/10ths, a 2 in the hundredths place stands for the place value.
Okay. So, what place value is this?
10.
Tenths. Make sure you put your THS in there. What place value is this?
10.
Hundreds.
Hundredths. Good. So, what's this number?
2.
2. And if it's in the hundredths place, what
Two
should be here?
hundreds.
200ths. What if the 2 was in the thousandths place?
2,000.
2,000ths. What if the 2 was in the 10,000ths place?
10,000.
Yeah.
20.
2 over what?
2 over 10,000.
Yes. So whatever place it's in is the number you put down here, okay?
200ths. And a 2 in the thousandths place stands for the place value 2,000ths. Knowing that will help us write decimal numbers in expanded form, like the one we saw earlier, 126.53. The expanded form of the whole number part is easy. We learned how to do that in the last video. 126 is 100 plus 20 plus 6. But now we need...
Okay, are we okay so far with this?
Oh, I got
So
how to
this
do
is
this.
expanded form.
Wait, I know how to do it though.
Good.
The
Okay,
standard.
so let's wait a little bit,
I
okay?
want to do it.
So are we okay so far here?
Yeah.
Yeah.
Expanded form. Now we're going to keep adding. So, what place value is the 5 in?
10.
Tenths. So it's going to be 5 over what? If it's in the 10th place, it's going to be 5 over what?
1,000?
It's in the 10th place.
Hundreds?
It's in the 10th place, so what goes under?
10.
Yeah, 5 over 10. The 3 is in what place?
Ones.
Right here.
1,000.
Hundredths.
Here, look
Hundredths.
here. Wait, look
So
at
what is the 3 going to be over?
I wrote it down.
What is the 3 going to be over? Over 100. Good job. So watch what he does.
To add the fractions represented by the decimal digits, too. Since there's a 5 in the tenths place, that stands for 5/10. So we need to add the fraction 5 over 10 to our expanded form. But we also have the digit 3 in the hundredths place, which stands for 3/100. So we also need to add the fraction 3 over 100 to our expanded form.
Okay. So what I was saying, so we understand how he got the 126 here. 100 plus 20 plus 6. Now, we're going past the decimal point, and this is the what place?
Tenths.
Tenths. So it's going to be 5 over what? 10. Plus, what place is this?
3.
Hundreds.
Hundredths. So it's going to be 3 over
100.
100. Do we all see how he got that?
Yes.
Okay.
All right, so that's a basic intro to decimal number places. There's still more to learn about them, and as you can see,
Okay. We're going to end here. Can
I
you please
see
turn
it.
on the lights?
I got it.
Thank you. Thank you. So, so we're going to use the same example that I used for my last class, which is right here. Okay. So, we have this number here. Let me move it. 3,612.4320. What place value is this?
Ones. Tenths.
Hundreds. Thousands.
Okay, good. So we know this, right? Now moving to the right of the decimal point.
Tens.
Tenths.
Yeah, tens.
Hundreds.
Hundreds.
Thousands.
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 10,000.
10,000.
10,000. What do we know this about this?
It keeps on getting higher.
It keeps getting higher, but
Yeah.
really the number's getting smaller, right? Remember,
Yes.
to the right, it gets smaller by 10. Or I should say probably divide by 10. And over here, it gets higher by 10. Okay, so how many zeros are here?
1, 2, 3, and 4.
Okay, so it's going to keep increasing. This can go on for
And then
infinity,
3.
okay? So if I said, right now we're talking about place value. If I said circle what's in your hundredths place, THS, what would you circle?
The 0, 6.
Hundredths place. Hundredths. Michael, if I told you to circle what's in the hundredths place, what would you circle?
0. Oh no.
3.
Yes, it's 3.
Oh, sorry, I was 10.
If I said circle what's in the 10,000ths place, what would you circle? So we're going to find the 10,000ths. And what's here?
The 0.
The 0, okay? If I said circle what's in the thousandths place, what would you circle?
2.
Good. If I said circle what's in the hundredths place, what would you circle? Yell it out.
3.
If I said circle what's in the tenths
4.
place,
4.
4.
what if I said circle what's in the thousands place?
3.
Good.
2.
What about in the hundredths
6.
place?
No,
Two.
wait,
I mean,
not 3. It's
In
2.
the hundredths place?
100 place. 6.
6.
In the tens place?
1.
In the ones place?
2.
Good. Okay, so that was place value. Are we clear on place value? Red, yellow, or green cards? Hold them up. Red, yellow, or green?
Use the cards if you understand.
Green means you understand, yellow is kind of, and red is I don't understand, start all over.
He was paying attention.
Okay. So, okay. So we're moving on to, so this was place value. Now we're moving on to expanded form. What are we talking about now? Expanded form. Okay. When we do this, we always start over here to the left, okay? So this is my thousands place. How many thousands do I have? 3. And how many zeros should I be adding? 3. 3. Plus, how many hundreds do I have? How many zeros should I have?
0.
Why 0?
I don't know what I meant to say.
Okay. How many tens do I have?
1.
How many zeros do I need?
1.
1. How many ones do I have?
0.
How many ones do I have?
Oh, 2. I'm looking at the bottom.
You guys don't just try yelling it out. How many ones do I have?
2.
I was looking at the bottom.
0.
Do I need any zeros after
No.
the 2? No, because there's no zeros here, okay?
I'm just
Now we keep adding, even after the decimal. How many tenths do I have?
4.
What is it going to be over?
Out of 10. Out of 10.
How many
3 out of
hundreds?
100.
What goes under 10?
2 out of
1,000.
1,000. 2 out of 1,000. 0 out of the 10,000s.
And over here?
0 out of 10,000.
10,000.
You have to tell me there's 0. You cannot just leave it out. Okay? 0 is a number. You need to let me know. Even if you wanted to write 0 over 10,000, that would still be fine. But you have to let me know it's 0. You could either just put 0 or 0 over 10,000, okay? Let's try another example.
I get it now.
Good.
I got it a while ago.
I get that one, but like the other one doesn't work. I don't feel like that. I get it.
Okay, so right now we're talking about place value. What are we talking about? Place value. So, we're going to the left of the decimal where it gets bigger. What is this place value?
1.
10.
100.
Now we're going to go to the right where it gets smaller.
Tens.
Tenths.
Yeah, I get tens.
Hundreds. Thousands.
1,000.
Good. Remember to put that THS after the decimal. Tenths, hundreds, thousands. So, this is place value. If I told you what place is the 2 in, what would you tell me?
10,000.
What place is the 2 in?
The 10,000s. Thousands.
Tens.
Tenths. Good job. Look. What place is the 2 in? Look under here.
2 out of 10.
What place is the 0 in?
0 out of
Thousands.
hundreds.
In the thousands. Good. You don't have to do that. We're not expanded form yet. We're talking about just the place value. So when I ask you the place value, you literally just tell me the thousands. Okay? When I ask you what place value is the 6 in, what would you tell me?
1.
10.
What about What about the 4?
100.
Hundreds. What about the 5?
10.
Tens. Because you're looking here. The 5 is in the 10 spot. If I ask you, once again, the 0, what place is it in?
In the thousands.
Thousands. Good. What about the 2?
10.
Tens. Good. And the 1?
100.
Hundreds. Good. Okay, so that was place value, okay? Now we're talking about expanded form. What are we talking about?
Expanded form.
What does expand mean? To make
More.
bigger. Good.
Bigger.
So we always start on the left-hand side. How many hundreds do I have? 4. Don't just yell. Think about it first. How many zeros do I need to put?
2.
How many tens do I have?
5.
How many zeros do I have?
1.
How many ones do I have?
6.
How many zeros?
0.
Yeah, because there's no
You
zero.
have 0 zeros.
So now we're going to keep going. How many tenths do I have?
2.
It's going to be over.
10.
Good. How many hundreds?
1.
Over
Over
100.
100.
How many thousands?
0.
0 out
Over
of 1,000.
1,000.
Can I leave this 0 out?
No.
I could?
No.
What?
I need to say I have 0 thousandths. 0 is a number. You need to let me know that, okay?
Okay.
So now with your cards, red, yellow, or green. I want to gauge where you're at. Red, yellow, or green. Hold it up.
You don't have any green, so. You still have one.
Okay, so let's do one more example.
I need to get one. For make sure.
Let's talk about place value again. Let's do a simple number. 32.10. Okay. Christopher, what place value is the 2 in?
Oh, yeah.
Hundreds.
Nope. What do we always start with?
Ones.
Ones. Good. What place value is a 3 in?
Tens.
Tens. Awesome. Now we're moving over to after our decimal point where we say our THSs, right? What place value is the 1 in?
Hundreds.
We always start with the
Tens.
tens. Good. So 1 over 10. And over here it's going to be our
100s.
good hundredths.
One.
Good. You could have said 100ths. That's fine. So you got this. This is your place value. So Christopher, if I told you what place value is the 0 in, what would you tell me?
The hundreds.
The hundredths. If I said what place value is the 3 in, what would you tell me?
The ones.
The 3.
The threes. Like
Where's the 3? What place value?
tens.
10. If I said what place value is the 2 in, what would you tell me?
The ones please.
Ones. And if I said what place value is the 1 in, what would you tell me?
Tens.
Tens. Good. So you understand place value, okay? Now let's talk about our expanded form, okay? So what are we talking about right now, Christopher?
Place values.
Expanded form. What are we talking about?
Expanded form.
Expanded form. When we do this, we're just adding it all together, okay? We're breaking it down. So see how this is my tens spot?
Yes.
I need you paying attention over here, please. Thank you. How many tens do I have?
Three.
Christopher, how many zeros are in this place? Look up here, please. How many zeros?
One.
1. So how many zeros am I going to put here?
Just one.
Yeah, good. So plus. How many ones do I have?
Just one.
Just two.
2. Do I need any zeros?
No.
No. Let him answer, please. How many tenths do I have?
One.
1. Good. And it's going to go over what?
10.
10. Okay. And we're on our last one. How many hundredths do I have?
10.
How many hundredths?
0.
0. Over what?
Over.
What's it over?
100.
100. Okay. This is expanded form.
Okay.
So where are you at? Red, yellow, or green? Okay, good. Where are you at? Red, yellow, or green? Did you turn to yellow or are you green? And then you're there? Okay. And what are you at right now? Okay, awesome. Okay, so now you guys are going to do a lesson I gave you on